Imagine a world where we store clean energy, not in batteries that wear out, but in giant, spinning machines so efficient they can power entire cities for minutes at a time, instantly. This isn't science fiction, this is the world's largest flywheel energy storage system. And it's changing the way we think about renewable power forever. A flywheel is one of the oldest mechanical technologies known to humankind. At its core, it's simple, a massive rotating disk that stores kinetic energy, the energy of motion, when you apply energy. It spins faster. When you need power, it slows down, releasing that stored motion back as electricity. But modern flywheels are far more advanced. They use carbon fiber rotors, magnetic bearings, and vacuum chambers to reduce friction, allowing them to spin at incredible speeds, up to 60,000 revolutions per minute. The basic principle has been around for centuries, but today's technology has transformed it into a powerhouse of modern engineering. So, why does the world need this technology now more than ever? Renewable energy sources like solar and wind are changing our world, but they come with one big problem: intermittency. The sun doesn't always shine, and the wind doesn't always blow. Traditional batteries can help bridge these gaps, but they have their own set of challenges. They degrade over time, are costly to replace, and often require mining for rare minerals like lithium and cobalt, which comes with its own environmental footprint. Flywheel systems, on the other hand, offer a compelling alternative. They can last for decades with almost no loss in performance, require no chemical materials, and can charge and discharge in mere seconds. This makes them absolutely perfect for stabilizing power grids and ensuring a constant, reliable flow of electricity, even when renewable sources are fluctuating. In 2025, a major milestone was reached when the world's largest flywheel energy storage system came online. This 500-megawatt facility, capable of delivering 250 megawatt-hours of energy storage, is a true game changer. Located in Massachusetts, it was built by Beacon Power in collaboration with global energy partners. Each individual flywheel in this massive array weighs several tons and is housed underground in its own vacuum-sealed cylinder to eliminate air resistance. Together, they create one of the fastest response storage networks in the world. So, what does that mean in practical terms? When the grid experiences a sudden demand spike, like on a hot summer day when everyone turns on their air conditioning, these flywheels kick in instantly. They keep everything from hospitals and critical infrastructure to massive data centers running smoothly, preventing blackouts and brownouts. So how does it all work? The process is a beautiful example of physics and precision engineering. Electricity from the grid powers magnetic motors, which accelerate the flywheel, making it spin faster and faster. As the flywheel spins, that energy is stored as pure motion. It's like coiling a spring, but instead of potential energy, you're building up kinetic energy when power is needed back on the grid. The exact same motor reverses its function and acts as a generator. It slows the flywheel's spin, converting that kinetic energy back into electrical energy with incredible efficiency. There are no chemical reactions, no emissions. Just the elegant conversion of energy from one form to another. It's a clean, simple, and powerful cycle when you put flywheel storage head-to-head with batteries. Its advantages for certain applications become crystal clear. There are 5 key features that make flywheels stand out. First is longevity. They can run for 20 years or more with minimal degradation, far outlasting most battery technologies. Second is fast response. We're talking millisecond-level reaction times to grid fluctuations, which is critical for stability. Third is sustainability. The materials used, like steel and carbon fiber, are 100% recyclable. Fourth is low maintenance, with magnetic bearings and a vacuum seal. There's virtually no physical contact or chemical wear and tear. And finally, scalability. These systems can be deployed almost anywhere. From large-scale grid support to powering remote communities and microgrids. While lithium-ion batteries are still the king for long-duration storage, like powering your home overnight, flywheels are absolutely unbeatable for delivering short-term high-power bursts to keep the grid in perfect balance. These systems aren't just a concept for the future, they're already being used in the real world today. Flywheel technology is powering transportation networks, ensuring that electric trains have the power they need to accelerate. They're at the heart of microgrids for industrial parks and remote villages. Providing stable power regardless of the main grid status, they're even going to space. NASA is actively testing miniature flywheels for satellites, which would allow them to maintain continuous operation even when they pass through Earth's shadow during an eclipse. Back here on Earth, major urban grids in cities like Tokyo, Berlin, and Dubai are adopting flywheel modules to reduce blackout risks and better integrate the fluctuating power from their growing solar and wind farms. As the world races toward a future of carbon neutrality, technologies like the flywheel are proving that innovation doesn't always have to be something brand new. Sometimes it means reimagining and perfecting the old. Flywheel energy storage is more than just a backup system, it's becoming the missing link in the renewable revolution. It's the technology that turns clean but intermittent energy into continuous, reliable energy that we can count on 24/7. The future of power is spinning, literally. Thanks for watching. And if you found this interesting, don't forget to like and subscribe for more looks into the technology that's shaping our world.